In our final video in the Acids and Bases series, we're going to learn about the naming system for oxyacids, the more complex counterpart to the binary acids. So remember that oxyacids are acids that contain a hydrogen that is attached to a polyatomic ion, and again, that polyatomic ion usually has oxygen as the overwhelmingly most common element, hence the term oxyacids. And we can see that using these chemical formulas here, that they both clearly contain hydrogen that is added on to one of the two polyatomic ions that we see here. And in fact, identifying what the polyatomic ion is actually key to understanding how the naming of the acid works. For example, the polyatomic ion NO3 with a -1 charge is known as nitrate, and the polyatomic ion with the chemical formula NO2 and a -1 charge is what we call nitrite. Now, these are relatively representative of most of the polyatomic ions that can make up acids, in that their suffixes are relatively predictable. Nitrate ends in the suffix ate, and nitrite ends in the suffix ite. And this will determine how the naming system is going to work for each of our given acids. For example, if the polyatomic ion's name ends in the suffix ate, as it does with nitrate, we remove that, so we don't have the ate on nitrate anymore, and we simply add the suffix ic acid or ic acid, as we did with binary acids. So HNO3, when it is in its acid form, is what we call nitric acid. Now, conversely, if our acid ends in the suffix ite, for example, nitrite, we remove that suffix. You can see that I didn't write an ite here, and instead of adding ic acid, we call these us acids, OUS acids. So this acid name would be pronounced nitrous acid, and this generally applies to every acid that is based on a polyatomic ion that ends in ate or ite, with two slight exceptions, and ththese exceptions are oxyacids that contain the element sulfur. For example, the polyatomic ion here, SO4 2- is sulfate, and polyatomic ions that contain the atom phosphorus, and I was writing out phosphate instinctively here, but it's the element that we're interested in, which of course is the element phosphorus that we see here. So, for example, with each of these acids here, the naming is a little bit of an exception, so we need to go over the spelling conventions that make each of these different. We'll start with the polyatomic ions that contain sulfur here. So SO4 2-, the polyatomic ion for that is sulfate, and if we remove one oxygen from the formula of sulfate but keep the -2 charge here, this polyatomic ion is called sulfite. Now, the only distinction in the naming system is the spelling, so we're going to start with the baseline of naming the element with the chemical symbol S, which is sulfur, and this is our root for naming both of these acids here. Now, when we are dealing with a polyatomic ion that has sulfur in it, we consider once again if our polyatomic ion ends in ate or whether it ends in ite, and apply the same rule as above. For this one that contains sulfate, SO4 2-, we, instead of adding the suffix ate, we just add the suffix ic acid onto the element name sulfur, so this is what we call sulfuric acid, whereas if we removed the ATE and replaced it with IC, we would just get sulfic acid, but that's not the spelling that we use in English. It would be sulfuric acid, hence using the element name sulfur as our baseline. Likewise, if the polyatomic ion like sulfite ends in ITE, instead of adding ic acid to sulfur, all we do is we add us acid, OUS acid, to sulfur, and we would end up with sulfurous acid. Now, the rule as far as compounds or polyatomic ions that contain the element phosphorus is a little bit different. We're still going to use the element name phosphorus as our baseline, but you can see that I've removed the suffix here. So if we compare the element name phosphorus with the polyatomic ion root in the acid, we see that we remove the suffix us from the element name here, so that we just have phosphor, and then the rule of ic acid versus us acid remains the same. If we have a polyatomic ion that ends in ATE, which we do over here because the polyatomic ion PO43- is phosphate. And if we have an acid that is based on phosphate, we, instead of writing ATE, would replace it with the suffix ic acid. So instead of adding 8 over to here, we take our phosphor and add ic acid onto the name, and this would be called phosphoric acid, instead of, if we removed the ATE and replaced with ic acid here, this would be spelled phosphic acid, but this is spelled incorrectly for the English spelling because, you know, how irritating and irregular a language English is, but that's the battle that we need to fight here. Now, this polyatomic ion here is PO3 with a -3 charge. So here, this would not be phosphate, but this would actually be phosphite. So here we see that our polyatomic ion ends in ITE, meaning that we would replace the US on our element name, so phosphor, but instead of adding ic acid as our suffix, we would add OUS acid or us acid. So the name of this acid would be phosphorus acid, like so. And following that, if you remember the slight deviations in spelling convention for sulfur-containing acids and phosphorus-containing acids, every other oxyacid is named in an identical way. So to conclude and see whether your knowledge of acids is complete, see if you can either identify the formula using the name of the acid or name the acid from the chemical formula that is given for all of the acids in this table here.